Hey guys, welcome back to Mrs. Nicol's at-home biology classroom. This is going to be your video for Thursday, May 7th. This is going to cover notes from section 13-5 and 13-6. I'm actually going to do them in the reverse order, so I'm going to do 13-6 first, then I'm going to do 13-5. The notes for 13-6 were actually on Google Classroom on Monday of this week. So it's a really short section of notes. If you don't have them in front of you, pause the video, get those. They were from Monday on Google Classroom, and then the notes for 13-5 were on today's Google Classroom assignments. You're going to kind of need both of those in front of you if possible as you're listening to this. So I'll hang on a second, pause it if you need to, and then come right back to me. So for section 13-6, it deals with pyramid models. There's a couple different pyramid models that you're going to see in that section. One of them is something called pyramid of biomass. Another one deals with energy. There's a few different ones in there. The one I want you to really focus on is going to be the one that deals with energy. And so that kind of goes back to what we talked about in section 13-4. That's why I'm kind of flipping these last two sections of the chapter. So for section 13-6, I'm going to have you look at the marker board that we looked at earlier this week. It's basically going to be the exact same diagram. So I'm just going to talk you through that again. So first of all, if you think of it kind of like tiers of a wedding cake or a pyramid, depending upon what you want to, how you want to visualize it, the widest part at the bottom is going to be where the producers are. The producers are in the widest part because they contain the most energy. As you go closer up to the top, there's going to be less and less energy. Now, keep in mind, we're not trying to say that energy is being created or destroyed. We're not trying to defy the laws of physics here and chemistry. What we are saying is that as energy moves up the pyramid, there will be less at each level. And that's partly because that animal's body is incorporating some of that energy. They're going to use that to do cellular processes like cellular respiration. In the process of doing that, they're going to give off quite a bit of heat. This is why all organisms give off body heat. They got that heat from the food that they ate. Remember, energy is a form, or heat is a form of energy. So, as for example, if a primary consumer like a rabbit eats a flower, which is a producer, only about 10% of the energy from the producer level is going to make it up to the primary consumer level. About 90% of energy, it's not destroyed, but it's lost. In other words, it's given off to the environment. In most cases, it's going to dissipate as heat, okay? So as you go up each level, only about 10% of energy moves up to the next level, and about 90% is going to either be used by that level or given off as heat. So the most energy is going to be at the bottom. That's why it's always the widest. The least amount of energy is going to be at the top because there's almost no energy left by the time you get up to that very top. Those tertiary consumers, these are apex predators. These are usually large carnivores. This is why a carnivore that is a tertiary consumer is going to need to eat often, and they're going to need to eat fairly large meals because they're not getting much energy every time they do eat something because so much of it has already been lost along the way going from bottom up to the top. Okay, now I'm going to talk about the section 13-5 notes. This was on Google Classroom's assignment for today. Section 13-5 deals with cycling of matter. We've already talked about some of these before, okay, in other chapters. Some of these you've been hearing about since probably early elementary school. The first one they mention is the water cycle, also known as the hydrologic cycle. So because they're cycles, cyclical means you can pick any point that you want to start at, and then you just follow the path of arrows through the rest of the cycle. You guys know that water comes down from the clouds. Anytime that comes down, that's considered precipitation. That's going to count as rain, sleet, snow, hail, whatever. It's going to land on the surface of the earth, on dirt or lakes, rivers, streams, whatever. Some of that is going to evaporate. Evaporation is going from from a liquid to a gas. Once that goes back up, it makes its way back up to the clouds, and the whole cycle just repeats over again, okay? Plants do a form of evaporation called transpiration. It's the same process, so liquid being converted to gas. We only call it transpiration when plants do this, okay? And they're going to do it from the surface of their leaves. And of course, once it gets up into the clouds, it will then turn back, it'll go into that gaseous state and eventually come back down as a liquid or as a frozen substance like ice or snow, okay? There are also some cycles called biogeochemical. These are going to be cycles that involve biology, geology, and chemistry, okay? One of those is the oxygen cycle, and this is going to cycle oxygen throughout the environment. We've already talked about this one before, even though we didn't call it that. When plants do photosynthesis, you guys know that they take in CO2, which includes oxygen, and they will then convert that into oxygen and give it off through the leaves of the plant. So, and then a consumer, like a person, is going to take in that oxygen, they're going to breathe it in, and they will then exhale it as CO2, and from that point, the plants take that CO2 back in, and they just do the whole process all over again. So the oxygen cycle is basically made up of two processes, photosynthesis and cellular respiration. Just to remind you guys, all organisms do cellular respiration, including the plants, okay? Carbon cycle. This is another biogeochemical cycle. This one's going to be cycling carbon throughout the atmosphere, throughout the environment. So it's going to look pretty similar to the last cycle in that when plants do photosynthesis, not only do they make oxygen, they also make carbohydrates. They make glucose, C6H12O6. They make sugar. When a person or some other consumer eats an apple or some other plant material that came from a plant, they're going to use that glucose, which is in the apple, they're going to use that to do cellular respiration with. And when they do cellular respiration, they're going to exhale that CO2, which again includes carbon. The trees or whatever other plants are going to suck that right back in again and do photosynthesis all over again. And the cycle just keeps on going, okay? Some other things that contribute to the carbon cycle would be burning fossil fuels. These are going to be anytime we're talking about gasoline or oil or natural gas. Anytime we burn those fossil fuels, we put CO2 into the air. Anytime you burn anything, it's going to give CO2 off as a product. Also, another part of the carbon cycle is decaying organic matter. Anytime anything dies, all organisms contain carbon. Even after they die, that carbon is still in them. So that carbon is going to end up in the soil thanks to gravity. When things die, they hit the ground. That CO2 that's in the soil will then eventually go back up into the air as gaseous carbon dioxide. Nitrogen cycle is another biogeochemical cycle. Most organisms can't use nitrogen in its gaseous form. Remember, nitrogen is normally a gas, so it needs to get converted to a more usable format. Most of the nitrogen cycle is going to happen underground. There will be bacteria that live deep underground. They're going to convert the gaseous nitrogen to ammonia, which is NH3. Ammonia gets converted to a different chemical substance called ammonium, and then eventually to nitrate, which is a different chemical substance. Nitrate just happens to be the form that plants need. Plants will take it up through their roots. Anytime we eat a plant or we eat an organism that ate a plant, we're getting that nitrogen into us. Now you might be wondering, why does anything need nitrogen? Well, you might remember Proteins are made up of nitrogen, and proteins are a component of all of our cells. DNA is also made up of nitrogen, and we know all about DNA. The last cycle is the phosphorus cycle. Phosphorus is a chemical element. Phosphorus gets cycled through the environment. Rocks contain phosphorus. When rocks are weathered, which means little bits and pieces of them get broken down, that falls in the soil thanks to gravity. Plants will take that up through their roots. Plants have to have phosphorus. They also have to have nitrogen in order to stay alive. So the plant will then contain it in its tissues. When the plant gets eaten by a consumer, like let's say a butterfly or some other primary consumer, now that phosphorus is in the butterfly's body. When the butterfly dies, thanks to gravity, it hits the ground, okay? Decomposers that are in the soil, decomposers would be things like fungi and bacteria. They're gonna break that dead butterfly's body down. That then returns that phosphorus right back to the soil. That soil then the phosphorus in the soil can then be taken up by another plant or maybe the exact same plant's roots. Now it's back up into the plant and the whole cycle can just repeat itself again. Phosphorus also happens to be one of the chemical elements that is found in nucleic acids, DNA and RNA. Okay, so that's how we're getting it into us. We as a consumer are getting it into us thanks to the phosphorus cycle. Hope you guys are doing okay. I miss you. Just to remind you, we're going to have a test over chapter 13 on Monday of next week. Thanks for watching. See you soon.